Hello everybody and welcome to a bonus short little video about being smart about graphing systems of linear equations. In order to start this video, I want to remind us of something we did in the last video. So remember, how can you quickly decide the number of solutions that a system has? Well, for one solution, you know that you're going to have different slopes and so therefore different lines. As long as you have two different lines, you will have one solution as long as their slopes are different. Okay? For the next one, in order to have no solution, what we're going to have is the same slope but a different y-intercept. And what we're going to wind up with when we graph these is we will have parallel lines. Parallel lines will always have no solution. Okay? And finally, to have infinitely many solutions, it means we're going to have both the same slope and the same y-intercept. And if you have the same slope and the same y-intercept, what you're really going to have is the same line. So you're going to have two lines that are actually the exact same line on top of each other, and that's why you'll have infinitely many solutions. So how do we use this to be smart about what we're doing? Well, let's look at this example right here. This is similar to what we were doing yesterday. We have the system of equations 4x plus y equals 5 and negative 2x minus y equals 5. Well, first thing I'm going to do is the same as always. I'm going to rewrite these two equations into slope-intercept form. For the first one, that means I have to subtract 4x from both sides, and I get that y is equal to negative 4x plus 2. On the next one, I need to add 2x to both sides, and notice what I have, negative y equals 2x plus 2, which will turn into y equals negative 2x minus 2. I can just flip the signs on every single term because that's really the same thing as multiplying everything by negative 1. Now, how does this help us? Well, what we can do is we can look back here and figure out which one of these situations is that. Do they have different slopes? If they have different slopes, then there'll be one solution. If they have the same slope and different y-intercepts, they'll have no solution. If they have the same slope and the same y-intercept, they'll have infinitely many. Let's figure out which one we have here. When I go to this next one, I notice my first slope is negative 4. My next slope is negative 2. If I have different slopes, let's go back again. Different slopes means I have one solution. As long as I know I have one solution, then I can continue graphing the normal way like I did yesterday. So I'm going to first, this was step 1b, is the step that I'm adding for today's video. Check the slopes and the y-intercepts for which type of system. And the type of system is here's what I'm going to write, I'm sorry. I'm going to write that I have different slopes, so one solution. And as long as I know I'm looking for a single solution, then I can go ahead and keep doing the same steps that I did in the last video. So let's go ahead and do that quickly. We know how to do it by this point. So I'm going to take that, I'm going to graph those two lines. I need to figure out what the two lines were. Y equals negative 4x plus 2. Y equals negative 4x plus 2. And the next one was y equals negative 2x minus 2. Y equals negative 2x minus 2. And I'm going to say my y-intercept for the first one is going to be, the coordinate of it is going to be 0, 2. And the slope is going to be negative 4. So the slope tells me to go down 4 and right 1. Okay, so I start at my y-intercept, which is 2. I'm going to go down 4. I go down to negative 2 and right 1. Down 4, down another 4 and right 1. Down another 4 and right 1. I run out of graph, so I will go left 1 and up 4. Up 4 and left 1. And now I have my first line. I'm going to do it in red. Okay. And so this line is going to be about like that. All right. So next one, I have y equals negative 2x minus 2. I know that my y-intercept, I'm going to start at negative 2. So I will start at negative 2. And my slope tells me to go, the slope is -2, so it tells me to go down 2 and write 1. And so I start at -2 as my y-intercept. I go down 2, right 1. There will be my next point. I go down 2, right 1. I think I already found my intercept in my intersection, but I'm going to keep going. Down 2, right 1, down 2, right 1. And I'm going to give myself a few points to the left as well. So up 2, left 1, up 2, left 1, up 2, left 1, up 2, left 1. Now I can draw my line. I'm going to draw a green line this time. It's going to look about like that. On your graph, you can probably get it a little bit more perfect than that. But notice, it really looks like my point of intersection is going to be right here. And the point of that, the point that appears to be is the point 2, -6. Okay, so that's the point that I'm going to check, 2, -6. On the next slide is I'm going to do the last step, 2, -6. I have to check to make sure this solution is correct. So I do 4 times 2 plus, oh, I'm still on my magic pen, great. So 2, -6. So I'm going to do 4 times 2 plus -6 equals 2. And I need to check that. 4 times 2 is 8 plus -6. 8 plus -6 is just 2, so 2 equals 2, and I know I'm good on that one. I also have to check the other one. -2 times 2 minus, and notice my y is actually negative, so minus a -6 equals 2. So I have -4 plus 6. Does that equal 2? Well, -4 plus 6 is 2, so 2 equals 2. I have a true statement there as well. So I know that this point that it appeared to be is definitely correct. Nothing new here. Now let's go to the new stuff. I have these two equations, -15x minus 2y equals 20, and 15x equals 3y minus 18. Now I want to solve each of these for y, and then do step 1b. Look what happens. Plus 15x, plus 15x. So I have -2y equals 15x plus 20, and then I'm going to divide everything by -2. Divide by -2, divide by -2. And so this is, let me give myself just a tiny bit more room. This is going to be y equals -15 over 2, x minus 10. On the next one, I want y by itself. Notice y is on a different side and x is on a different side than I'm used to. So what I'll just do now is add 18, because I'm trying to get y by itself. I have 3y equals 15x plus 18. Now what I'm going to do, because this doesn't really look real pretty, so I'm just going to flip them. 3y equals 15x plus 18. That looks a little bit better. Now I know clearly the next step is divide by 3, divide by 3, divide by 3, and I get that y is equal to 5x plus 6. And at this point, I am going to check my slopes and my y-intercepts. I notice that my slopes and my slopes are different, so I am going to have an intersection, which is not what I meant to have happen. I clearly did something wrong with this. I'm trying to figure out where it is. I must have just made a mistake when I put these two examples together. I apologize for that. I'm going to skip ahead because this doesn't, oh, we already know how to do this. I'm going to go to this next one here, and I think that'll be the last one we do. Yes, it will be. Because really what I'm looking for, I want to show you what happens when we don't have one solution. So let's go with this one. 3 halves y plus 3 halves x equals 6. And -4x minus 4y equals -16. Let's see what happens here. First thing I need to do is subtract 3 halves x from both sides, so minus 3 halves x. I get 3 halves y equals -3 halves x plus 6. Next, I need a little bit more room because I can't write fractions real well with my big fingers. All right, and so the next step is going to be I need to get rid of this 3 halves. Well, I get rid of 3 halves times a number by multiplying by the reciprocal, so times 2/3. The 2's cancel out, the 3's cancel out, I'm just left with y. But then I need to do that with everything, times 2/3 times 2/3, and look what happens. I get that y equals, these 2's will cancel out, the 3's will cancel out, but I still have the negative, so negative x, and then 6 times 2/3, the 6 and the 3 will reduce, 6 becomes 2, 3 becomes 1, I just have 2 times 2, so it's negative x plus 4. I'm going to group some of this stuff and shrink it down so I can do the next problem as well. Oops. Great. And then I can move all of this stuff over. Y equals negative x plus 4. Now I'm going to do the next question. Plus 4x plus 4x. I get negative 4y equals 4x minus 16. Divide by negative 4. Divide by negative 4. Divide by negative 4. Let's see what happens. I get y equals 4 divided by negative 4 is negative 1. So negative 1x is just negative x. And negative 16 divided by negative 4 is positive 4. Now I'm going to check my slopes and my y-intercepts. Notice the slopes, negative 1 here, and negative 1 here, tell me the slopes are the same. I check my y-intercepts. I have the same y-intercept. Look what I can do now. I can go back to this table here, which I want you to do every time you solve one of these by graphing. Where do I see same slope, same intercept? Right here. So I know my solutions are going to be infinitely many before I do any graphing. So what I'm going to say to do right here is before I do any of this, just write same slope. I'm going to write same m and b. So infinitely many solutions. Or SOL''N, infinitely many solutions. And look what I can do now. Don't need that. Don't need that. I'm done. You see how much work you save yourself by just adding this one step, this step 1b. After you solve for your 2 equations into slope-intercept form, check the slopes and the intercepts against this table that I gave you in the beginning. Check to see, are they different slopes? Then you'll have one solution, you do everything like normal. Are they the same slope but different y-intercepts? Then there'll be no solution because they're parallel. Is it the same slope and the same y-intercept? Then you have infinitely many. So you do not need to do any more work if it's one of those later 2 cases. Okay, I'm going to give you 2 questions to do on your own, 1 and 2, and I am done.